The chapter is real numbers for standard 9. This is continuation, the part 2, the continuation of the previous concepts. So properties of irrational number. So we learned what is rational number and what is irrational number in part 1. We are continuing with that. If a is a irrational number, then minus a is also an irrational number. And if you add rational number and an irrational number or subtract, it is always an irrational number. Similarly, when you multiply or divide a rational and irrational, it is always an irrational number. So rational and irrational, whether it is addition, subtraction, multiplication or division, it is always an irrational number. But if you add irrational with irrational, subtract, multiply or divide, it can be either a rational number or an irrational number. Now surds. Surd is a special type of irrational numbers. So an irrational number which is of the form nth root of x is called a surd. Actually, nth root of x is x to the power of 1 by n. That is, the power is a rational number, 1 by n. Here you call x as a radicand and n is called the order of the surd. And here this radicand has to be a rational number. That is the condition for that number to be a surd. So radicand has to be a rational number. So consider this example, cube root of 4. So 4 is a rational number. So it is a surd. Here if you see 1 plus root 3, cube root of 1 plus root 3. Root 3 is a irrational number. 1 is a rational number. You are adding rational number with an irrational number. It is a irrational number. So this condition is not satisfied. So it is not a surd. Here cube root of 8. So you can write this as, actually this is not a surd because cube root of 8 can be written as 2 to the power of 3 into cube root of 2 to the power of 3, that is equal to 2. So this is a rational number. So cube root of 8 is a rational number, and of course root 2 is a surd. The laws of surds is similar to the laws of exponents. Nth root of a into nth root of b is equal to, you can write it as nth root of a into b. Similarly for division also, nth root of a divided b. But you can't use the same thing for plus and minus. So nth root of a plus nth root of b is not equal to nth root of a plus b. The same for the difference also. Now nth root of x is equal to mn. You have to multiply these orders. So mn nth root of x. Now coming to similar surds. You can add or subtract only with similar surds. So we have to understand what is similar surd. That is root 2, 2 root 2, 25 root 2. So these are called similar surds. The irrational number, the same irrational number, but the coefficient can be different. So you can add. Now this, if you add this, this will be 25 plus 2, 27 plus 1, 28. So add, subtract, multiply, divide is possible in similar surds. So root 2 plus 2 root 2 plus 25 root 2 will become 28 root 2. Root 2 into 2 root 2 is equal to 2 into 2 is equal to 4. 2 root 2 minus root 2, again it is possible because it is similar surds, and you can also divide. Dissimilar surds, here this root 2, here it is root 3, here root 5. So they are not similar surds, so they are called dissimilar surds. And addition and subtraction is not possible in dissimilar surds. But you can do multiplication and division. Only addition and subtraction is not possible with dissimilar surds, but with similar surds, all the 4 operations is possible. When you keep doing the problems, you will become familiar with these laws. Now, root 2 into 2 root 2. If you multiply, you get 2 into root 2 into root 2 will become 2, that is equal to 4. Now, if you see, these are similar surds. But here they are not similar. Root 2 and root 3, they are not similar surds. But you can multiply here 3 into root 2 into root 3 can be written as root of 2 into 3. So, 3 root 6. Similarly, here cube root of 2 into cube root of 5. You can write it as cube root of 10. So, you can multiply or divide the surds of the same order. Now, if you see here, you cannot multiply root 2 and cube root of 3 because their order are not same. So, here also because the order was same, you are able to multiply. Root 2 and root 3, the order is 2. So, you could multiply, but here the order is 2 and here the order is 3. So, you cannot multiply. So, but we can do it by making the orders same. So, we will do that. When you do the problems, you will be able to understand. Before that, we'll do some simple problems. Root 48 is equal to, you can simplify it as root 48 is 16 into 3. You can write this as root 16 into root 3. So, root 16 is 4. So, 4 root 3. So, this is called a pure surd and this is called a mixed surd. Like mixed fractions you do, this is called mixed surd. Similarly, 4 root 3, if you have to, this is a mixed surd, you have to convert it into a pure surd. For that, you can write, because the order is 2 here. So, we will write this as root of 4 squared into root 3. Now, the order has become same, 2. So, now you can take it together. So, it will become 16 into 3, 48. Consider one more example. Cube root of 144. We will write 144 as 8 into 18. Now, 8 can be written as 2 into 3. Because this is 3. If you write 2 into 3, then we can write, take out 2 outside. So, 18 is 9 into 2 or 3 squared into 2. So, that we cannot do anything with this cube root. So, we can write 2 into cube root of 18. So, simplify this term. So, root 6 is at 216 and 96. So, let us write 216 factorize and write 36 into 6. So, we can write this as 6 minus root of 36 into 6 plus root of 96 can be written as 16 into 6. Now, this is equal to 15 root 6 minus 36 can be written as 6. Root of 36 is 6. So, 6 root 6 minus root 16 is 4. 4 root 6. Now, if you see, all are similar surds. So, you can add and subtract. So, 15 plus 4, 19. 19 minus 6 is 13 root 6. Here, 250, 16 and 54, we will try to factorize. So, 250 is equal to, we can write it as 125 into 2. So, we will write this as 125 can be written as 5 cube. So, 5 cube root of 125 into 2 plus 7 cube root of 16 can be written as 8 into 2 minus 14 into cube root of 54 can be written as 27 into 2. Now, this is equal to 5 into, this can be written as cube root of 5 cube into 2 plus 7 into cube root of 2 cube into 2 minus 14 into cube root of 27 can be written as 3 cube into 2. Now we can take this 5 outside. So 5 into 5 cube root of 2 plus this 2 can come out. So 7 into 2 into cube root of 2 minus 14 into this 3 will come out, 3 into cube root of 2. So this is equal to, now we can write this as, now if you see, 25 cube root of 2 plus 14 cube root of 2, 42 cube root of 2. Now if you see, all these are similar surds, so you can add and subtract. So this comes to 25 plus 14 minus 42 will come to 3, then cube root of 2. Now here root 48 can be written as 16 into 3. So we'll write this as 4 root 3 plus 3 into 16 into 3 minus 5 by 2 into, now this can be written as 3, I am multiplying 1 into 3 by 3 into 3, so that the value does not change. This is equal to 4 root 3 plus 3 into 4 can come out. Root 16 is 4. So 3 into 4 and root 3 minus, now here 5 by 3 into 3. Root of 3 into 3 is 3. So 5 by 2 into 3. It is in the denominator. So here also it comes in the denominator. And this will become root 3. The purpose of doing this is to make everything like surds so that you can do the addition. So this is equal to 4 root 3 plus 12 root 3 minus 5 by 10 root 3. Now all are similar surds. So if you, 2 into 3, 6, sorry. Now taking the LCM and doing, you will get this as 4 minus 5 is root 3. So this will become 91 by 6 root 3. So that's the answer.